Have you ever dreamed of hopping into a DeLorean and zipping back to the 80s or maybe visiting the distant future? What if I told you that time travel is real? It's happening right now. In fact, you're a time traveler. We all are. We're constantly moving forward in time, 1 second at a time. But here's where it gets really interesting. That 1 second at a time isn't the same for everyone. This isn't a sci-fi movie plot. It's a fundamental principle of our universe, described beautifully by one of the greatest minds in history, Albert Einstein. His theory of relativity completely changed our understanding of space and time. Before Einstein, we thought of time as this universal clock, ticking away at the same pace for everyone, everywhere. But he showed us that's not true. Time is relative. It's flexible. It can be stretched and squeezed. So how does this work? Imagine you're on a train. To you, everything inside the train seems normal. But to someone standing on the platform watching you zoom by, things look different. Einstein realized that something similar happens with time when you start moving really, really fast. The faster you travel through space, the slower you travel through time. Let's break that down. Picture two twins. One stays here on Earth, while the other blasts off in a super-fast spaceship, one that can travel close to the speed of light. After what feels like a year to the space-traveling twin, they return to Earth. They've aged 1 year. But back on our planet, decades, maybe even centuries, could have passed. Their twin on Earth would be old, or perhaps long gone. This isn't science fiction. It's a proven phenomenon called time dilation. For the astronaut, time literally slowed down. You might be thinking, okay, that's a cool thought experiment, but has this ever actually happened? Yes, it has. Albeit on a much smaller scale. Astronauts on the International Space Station are orbiting the Earth at about 17,500 miles per hour. That's incredibly fast. Because of this speed, combined with the slightly weaker gravity they experience, they age just a tiny bit slower than we do down here. When they return to Earth, they are a few milliseconds younger than they would have been if they'd stayed put. It's a minuscule amount, but it's measurable proof that time dilation is real. They have, in a very real sense, traveled into our future. So, traveling into the future is possible. We just need to figure out how to build spaceships that can get us close to the speed of light. A massive engineering challenge for sure, but it doesn't violate any known laws of physics. But what about the other direction? What about traveling back in time? To warn your past self not to get that terrible haircut, or to see the dinosaurs roam the Earth. This is where things get much, much trickier. The physics is far more speculative and, frankly, mind-bending. One of the most popular ideas for backward time travel involves something called a wormhole or an Einstein-Rosen bridge. Imagine space-time as a giant sheet of paper. To get from one point to another, you'd usually travel across the surface. But what if you could fold the paper over and poke a hole through it, creating a shortcut? That's the basic idea of a wormhole, a tunnel through the fabric of space-time that could potentially connect two different points in time. It sounds amazing, right? But there's a catch, a big one. To keep a wormhole stable and open long enough for something to pass through, you need a type of exotic matter with a bizarre property, negative mass. We've never observed anything with negative mass. It might not even exist. So for now, wormholes remain firmly in the realm of theory. Another mind-boggling concept involves black holes. These are regions of space where gravity is so strong that nothing, not even light, can escape. Around a spinning black hole, there's a region called the ergosphere, where spacetime itself is dragged around. Some theories suggest that if you could navigate this region in a very specific way, you might be able to travel along a closed time-like curve, which would essentially loop you back into your own past. However, the conditions would be so extreme and dangerous that it's a purely theoretical playground for physicists, not a practical travel plan. The biggest hurdle for backward time travel isn't just technology, it's logic. This brings us to the famous grandfather paradox. What if you went back in time and prevented your grandparents from ever meeting? If they never met, you would never have been born. But if you were never born, you couldn't have gone back in time to stop them in the first place. It creates a contradiction that seems to make backward time travel logically impossible. Some physicists propose solutions, like the idea of parallel universes, where your actions create a new timeline instead of changing your own. But these are just ideas, without any evidence to back them up. So, while going back to the past remains a distant, perhaps impossible dream, we can still look into it. In fact, we do it every single night. When you look up at the stars, you're not seeing them as they are right now. You're seeing them as they were in the past. Light, as fast as it is, still takes time to travel across the vast emptiness of space. The closest star system to us, Alpha Centauri, is about 4 light-years away. That means the light we see from it tonight left that star 4 years ago. We are literally seeing Alpha Centauri as it was in the past. For more distant stars and galaxies, this effect is even more profound. The Andromeda Galaxy is 2.5 million light-years away. When we look at it through a telescope, we're seeing light that began its journey 2.5 million years ago, long before modern humans existed. In this sense, every telescope is a time machine. The farther it can see, the deeper into the past it can look. The James Webb Space Telescope is giving us images of galaxies as they were over 13 billion years ago, near the very beginning of the universe. So time travel is a real, fundamental part of our universe. We're all hurtling into the future, and we can even peer deep into the cosmic past just by looking up. While building a time machine to visit the past might not be in our immediate future, the universe has already provided us with ways to experience the weird and wonderful nature of time. Who knows what future discoveries will reveal? The next breakthrough could be just around the corner. Thanks for joining me on this journey through time. If you enjoyed this and want to explore more amazing science concepts, don't forget to hit that like button and subscribe for more videos. Let me know in the comments what time period you would visit if you could. Until next time, keep looking up